Have you ever wondered if what you know about space is all true? Let's take a step back and unravel some common misconceptions. You see, when we think of space, images of a freezing cold or a blazing hot environment often come to mind. But is that really accurate? Let's start with the basics. Space is a vacuum, essentially devoid of matter. And if you recall from your high school physics class, temperature isn't a property of empty space, it's a property of matter. Therefore, saying that space is cold or hot is a bit of a misunderstanding. Now, another common belief is that heat radiates into space, but what does that really mean? We often imagine the sun sending out little packets of energy or photons traveling all the way to Earth. But this isn't quite how it works. Radiation is an oscillating force, not a stream of traveling photons. It's like holding two magnets in your hands. When you move one, you can feel the other one react, right? That's similar to how radiation works. The atoms on the sun's surface oscillate, and this oscillation instantly reaches the atoms on Earth's surface. So, when we say that heat radiates into space, it's not about sending heat energy into the vacuum. It's about this oscillating force between the sun and the Earth. Think about it. If heat could simply radiate into space, we wouldn't need complex cooling systems for our spacecraft. We could just let the heat radiate away into the vacuum, right? But that's not how things work. So if space is not cold or hot and heat doesn't radiate into space, what else have we been misinformed about? We'll continue unraveling the truth about space in the next scenes. Stay tuned to get your facts straight about the final frontier. Let's dive into another widely accepted belief: space travel. Is it really as we perceive it? Many of us have grown up with the idea that rockets can traverse the vast expanse of space, reaching destinations like the Moon or Mars. But let's take a moment to consider the mechanics of rocket travel. Rockets operate on the principle of fuel ejection. As the rocket's fuel burns, it expels gas at high speed, creating thrust that propels the rocket forward. But here's the thing, this method is not as efficient as you might think. In fact, a rocket would need to refuel every few thousand miles. Picture a highway stretching across the cosmos. You wouldn't get very far before you'd need to pull over for a fill-up. So the notion of a rocket making a non-stop trip to the Moon or Mars, with our current technology, it's simply implausible. Now let's switch gears and talk about light. We've been told that light from the sun takes approximately 8 minutes and 20 seconds to reach Earth. But what if I told you that light might actually travel instantaneously? This idea challenges the widely accepted theory that photons, particles of light, journey through space to reach us. Instead, it suggests that light, as an oscillating electric force with a visible frequency, is instantaneously present throughout space. So what does this all mean? It suggests that our understanding of space and the mechanisms that govern it might not be as accurate as we've been led to believe. The idea of rockets traveling to the Moon or Mars, or light taking time to reach Earth, are perhaps not as accurate as we've been led to believe. What if the way we understand heat radiation is completely wrong? We've always been taught that heat radiates into space, but let's flip that concept on its head for a moment. Heat radiation might not be about heat escaping into the vastness of space at all. No, instead it could be a phenomenon that's tied intrinsically to matter itself. So imagine a world where heat doesn't radiate into space. What would that mean for us? Well, for starters, we wouldn't need cooling systems. We could simply design a vehicle container to allow heat to radiate into it, and voila, we'd have a built-in cooling system. But alas, we do need cooling systems, don't we? That fact alone should make us question our understanding of heat radiation. So the concept of heat radiation as we know it may need to be reconsidered, along with many other beliefs we hold about space.